Hello everyone, welcome back to the channel. So we are going to start a series in which we'll be doing structural analysis using the finite element method, and we are going to be using Python and a library called calfem. So in most finite element analysis, I think we have three major steps, which is the pre-processing. This involves like the geometry definition, the element types, material properties, and meshing the model, setting up the physical constraint, and defining load or forces. Then we have the solution, which involves mainly calculating the primary field variable, that is like the displacement, and also from the displacement you can compute the secondary variable like the reaction forces and the stresses. And finally you can do a pre-processing, which like you analyze the result by sorting, printing, and plotting them. So in this episode today, we have a spring system and we want to calculate the displacement and the forces in the spring. So the first thing is we are going to define the model, or let's start by importing the library, the calfem Python library. From there, we can import our numpy library and also import the calfem. Okay, from there, let's define the topology matrix for the system. The matrix contains the element number and their corresponding global degree of freedom. So we are using the numpy array to define this, the degree of freedom at the various nodes of the element, and we are storing it in the variable called EDOF. Next, we initialize the global stiffness matrix K and the load or force vector F. We know that we had a load of, let's assume, of 100 Newton, and is applied to the second spring. So from there, we now define the element stiffness matrix for each spring. We use the function spring LE from calfem. These spring constants are defined as K and 2K, with K assumed to be 1500. You can look at the diagram for better understanding. Then from there, we now assemble the element stiffness matrix into a global stiffness matrix K using the topology defined in our EDOF variable. Now that we have the global stiffness matrix, we can define the boundary condition. In this case, the first and last degrees of freedom are fixed. So we use a numpy array to also define this. We use the solve equation function from the calfem library to solve the global system of equation, taking into account the boundary condition. Then from there, we output, or we print out our displacement, which is stored in the variable a. And once the displacement are computed, we can evaluate the element forces. First, extract the displacement for each element using the extract ed function. So when you remember, we discussed about computing the primary field variable, which is the displacement. Then from there, we can compute the secondary field variable, which can be the reaction forces or the forces in the spring. So we use the spring ls to calculate the forces in each spring, and finally we can display our results to show how it looks. So I hope you enjoy, and we are going to improve our videos. Please like, share, comment, ask questions, and subscribe to this channel. We are going to be doing a series of finite element analysis using Python, mainly for many structural members and system. Thank you for watching.